What's 14 asking me? 14 says 2 cosine squared of 22.5 degrees minus 1. We did need to recognize that this was a double angle, but backwards. So if I go ahead and take a picture real quick and erase that stupid line I just made and wait for those pencils to get sharpened. We're going to see that it matches up pretty closely with this right here, that 2 squared x minus 1. Well, if I have 2 cosine squared x minus 1, we can go back and make that cosine of 2x. So if I come back here, remember, I'm kind of picturing this as that x. This would equal our double angle. Our double angle says that equals cosine of 2x. So we'd have cosine of 2x, which would be 2 times 22.5 degrees, which would actually equal cosine of 45 degrees, which we can go one step further because that's on my unit circle, and that's square root of 2 over 2. Okay. Other questions? Yeah.
Were you supposed to go that far?
You go as far as you can. Yep. If it's on the unit circle, we should give a unit circle value. Always. Other questions? Kind of like, the way I look at it is if I say, if my answer ends up being square root of 4, I should give 2 as an answer, not square root of 4. But if it's square root of 3, I leave it as square root of 3. You go as far as you can on it. Questions? Okay, then let's make sure all computers and cellular devices are in a manner that we're not staring at those instead of doing the lesson. Oh, in fact, the lesson isn't even up. This is a good simplification one because we could start by distributing it, but we're going to notice something off about this one. I'm going to try to simplify this part first. So I'm looking at this cosine beta tangent beta first. I'm just focusing on that, and I'm like, well, what if I make that in terms of sine and cosine? Cosine remains, so I'd have cosine beta. Tangent, we would change, tangent, is that cosine over sine or is that sine over cosine?
Sine over cosine.
It's sine over cosine. Sine beta over cosine beta. Our cosines would actually cancel out. I'm actually left with just sine beta. So this is really just sine beta plus 1, sine beta minus 1. And it should be kind of something we look out for because how many times have we done difference of squares in this class? A lot. Like most of the times we do the multiplication, usually we don't have to distribute it. Usually it's a difference of squares. It's not every time, but that should be the first thing I think about. Is this a difference of squares? Well, this is a difference of squares. So I just need to realize that it's a squared minus b squared. So this is going to become sine squared beta minus 1 squared, which is just 1. Can I go further, though?
Yes.
What does that equal?
Cosine squared.
Ooh, I heard the right answer and I heard a couple wrong answers. It is negative cosine squared beta. Because if we just took a quick second and we wrote out the fact that this has to be sine squared beta plus cosine squared beta equals 1. In order to subtract 1, I would move it that way. But to get the cosine to the other side, I'd have to subtract that cosine squared. So that would equal a negative cosine squared beta. Subtract 1 from one side, and I have to subtract that cosine squared from the other side. So take that extra second, get that question right. Questions on that one, though? All right, now we're going to get to the hardest verifying identity that could possibly be on the test. Sure. Let's see why it wouldn't be. All right, and this one was, we're supposed to verify that sine of, I don't like that picture. I don't know why I'm so zoomed out. That's better. All right, so we have to verify that sine of 3x equals sine x times the quantity 3 times cosine squared x minus sine squared x. Now, in my mind, the right side's more complicated. But something trumps things being complicated, and that's when weird stuff appears. This is weird. This isn't just x. Kind of like if you have a negative x, you need to do something with the negative. If that's not just regular x, this has to be where you start. We have to make that a regular x. You just have to, because the other side are just x's. So I have to do something with that 3x. You cannot divide for a plethora of reasons. First reason, the very first day we did verifying, you cannot divide things on both sides. We have that wall that stops that from happening. Second thing is this sine times 3x? No, it's sine of 3x. So you couldn't divide even if I wanted to. So we have two reasons we cannot divide.
You can bring it out.
Well, it's not a multiplication once again. It is a triple angle. So we go to our sheet, we find our triple angle formula. Do we have a triple angle formula? No. What's the biggest one we have? A double angle. So this does not fall in the privy of that card, so you need to alter something to put it on the card. What I'm going to actually do is I'm going to rewrite this as sine of 2x plus x. And now I'm going to treat it as a sum. Do we have a formula where we add angles together?
Yes.
How does that work for sine? If I'm adding two angles of sine, what can I rewrite it as?
Sine A plus sine B plus cosine A.
Sine B. Yeah. So we're going to use the angle sum to rewrite this as sine of the first angle. The first angle is actually 2x. So we have to use the entire thing. This entire thing is the angle. So we're going to have sine of 2x times the cosine of our second angle, which is x, plus cosine of our first angle, which is 2x, and then sine of x. All right, so the first part, it's not hard, you just haven't seen it yet. Well, we saw it partially when we did our angle sums, so it's just something we need to be able to do. Now, what makes this hard is the next part. We need to get rid of the 2x here. So the first thing I want to look at is this guy. Is that a double angle formula? Is that 2 times something? That is our double angle formula. How can I rewrite sine of 2x? 2 times sine x cosine x, right? So we're going to rewrite this as, maybe I'll put in parentheses just for the sake of this. So we'd have 2 sine x, I'll just leave it like that, cosine x. And we still have that cosine x there. Here's where the real problem comes in, and it's that cosine of 2x. Is that a double angle? Yes. Do we just have one way to write cosine of 2x?
No.
There are 3 different ways to write it. And only one of those ways gets you your correct answer. So here's how we decide which one to use. So let me look at my sheet again for double angles. My double angles for cosine. We have 3 options. We can write it as cosine squared, sine squared. I'm just looking at the sine squareds and cosine squareds. I could write it as 2 cosine squareds, or I could write it as 2 sine squareds. Obviously, we got the ones in there and stuff. Our job is really to look at the other side and see what I need to create. Do I need to create a lot of cosine squares, a lot of sine squares, or not a lot of them? So our goal is to locate what do I want to create here. I didn't miss anything, did I? All right, so does the right side have cosine squareds and sine squareds?
Yes.
Does the right side have sine squareds and cosine squareds?
Yes.
Yes. So that probably means I want to use the one that has cosine squareds and sine squareds in it. For instance, if for some reason I could if that cosine squared wasn't there, let's say that's gone. Notice how I would just have sine squareds. I'd probably want to pick the one that just has sine squareds in it. So I might pick the 1 minus 2 sine squareds. But because we have sine squareds and cosine squareds on this side, we need to pick the right one, and my guess is it's the one that has the cosine squareds and the sine squareds in it. So at this stage, we have to pick the right one. You could pick one at random, but let's pick a smart idea. The smart idea is look at the right-hand side and go, okay, there's cosine squareds and sine squareds. Let's pick the one that creates cosine squareds and sine squareds, and that's our cosine squared x minus sine squared x. In fact, it's probably a good sign that this already matches kind of what the other side looks like. Notice the other side already has a cosine squared minus a sine squared. So that's probably the right pick. Now we still have a sine x here. Now the rest is algebra. 2 sine x cosine x times cosine x. Well, cosine times cosine is cosine squared. So on that left one, we're going to have 2 sine x cosine squared x plus, we're going to make sure we distribute the sine x to both of these because they're attached by subtraction. So we're going to have a sine x cosine squared x. And then we'll have a sine cubed x, it looks like. See how we have 2 sine cosine squared plus another sine cosine squared? That means you're going to have 3 of them, combining like terms. This right here, let me highlight it in green, matches this right here.
So for the 2 sine x cosine x times cosine x, that the cosine x doesn't distribute.
It doesn't, because it's multiplication. It's kind of like if I had, picture this, if I had 2 times 3 times 4, that 4 doesn't go to both things.
Then for the other
Even if you put parentheses around it. For the other one,
oh, because it's minus.
so remember how PEMDAS works. You have to do your multiplication first. Well, the problem here is I have to do this addition first. So normally I would do 4 plus 2 would give me 6. And then I'd multiply by 3. But if I replace that 4 and 3 with x and y, I can't do the addition first. So that means I must distribute this 3 to both things, because that allows that addition to happen first. For a multiplication, it's just a chain. It's commutative property. You can put parentheses around anything. It doesn't distribute to both things. Is that a little clearer? Okay. All right, so we have 2 sine x cosine squared x plus 1 sine x cosine squared x. That gives us 3 sine x cosine squared x minus that sine cubed x. I guess I can put my equal sign way out here. Here's kind of my wall. I didn't really build one this time because I wasn't sure how far I'd have to go out.
2 cosine.
It's 3 of them because I have 2 of them here plus another one would give me 3 of them. I'm combining like terms, just like if I have 2x plus 1x, you have 3x. This sine x cosine squared x appears twice, so I have 3 of them.
Oh, okay.
All right, now I'm going to notice that we have this cubed here that I don't have on the other one. Well, that means I'm just going to factor out a sine x. I'm going to factor out 1 sine x from both of these, which is going to leave me with sine x times 3 cosine squared x minus, well, sine cubed x when I pull out 1 sine x would be sine squared x. And it just so happens to match the other side.
That was a lot.
It is not that much. All of the steps follow. The only really hard step is this one. So if I was going to put this on the test, I probably wouldn't pick one that looks like this. I'd probably pick one that already has sine of 2x in it that You just have to realize that at some point you need to make a decision. Now, I give you all of these. That whole double angle, half angle stuff, that's all given to you. So it's just your job to realize that there's 3 of them, and you just look at the other side to determine which one to use. That's why I say this is always a valid one to put on a test, because it really gets across who's practicing this stuff and who is not. All right, questions on that?
I have a lot of questions.
Okay.
I keep it practice.
Okay. Do you have any questions I can answer right now?
Yeah, you would have to like re-explain like everything you just did.
Okay, yeah, I can't do that. Okay. All right, let's do another one. I look at this last one, whenever I put it up there. I'm going to notice that we have these x over 2's now. I have these x over 2's now. Oh, Jason, you don't have these notes, do you? Oh, you should have said something. I have them. Because you need the other notes too. There you go. All right, so we have tangent of x over 2, cotangent of x over 2. Our job is to make sure that those x over 2's, we get rid of those. Well, anytime we have something weird inside the parentheses minus a negative sign has to be memorized. Like cosine of negative x becomes positive cosine x. Everything else, if it's weird in there, you just go to your sheet. I go to my sheet and I'm like, oh, those look like half angles. Those are definitely divisions. So I'm looking at my half angle ones. And I have all these different half angle ones. Now, here's kind of our problem though. I picked really difficult ones again. Because what do we notice about tangent half angle ones? There's 3 of them. Remember I said yesterday you get to pick your own? Today, because it's verifying, you don't get to pick your own. So here's what we need to recognize here. I'm actually going to look at the other side. I'm going to look at the other side for just a second. What is cosecant in terms of sine and cosine? It is 1 over sine. Notice that sine is in the denominator. Sine is in the denominator. When I pick a tangent half angle, I should probably pick one that maybe has sine in the denominator. Is there one that has sine in the denominator? Yeah. There is this one. So I'm going to pick this one because that already puts sine in the denominator. So I have my 1 minus cosine over sine x. So that tangent x over 2 becomes 1 minus cosine x over sine x. That's just me reading a sheet that will be given to me on the test and me realizing that I want to put sine on the bottom to match that sine on the bottom there. Do we have a cotangent half angle formula? No. But what's cotangent in terms of tangent? Cosine over sine, that's one way. The reciprocal of tangent, right? So this is really just 1 over tangent. So it's plus 1 over tangent x over 2. Okay, so I haven't done anything to the left one. Let's leave that alone. We have 1 minus cosine x over sine x. I do have to use a half angle formula for this tangent x over 2. But remember, that 1 on top of it, when you have 1 over something, it flips the fraction. So if I have 1 over 1 half, it becomes 2 over 1. So whatever we do, we're going to flip it. So keep that in mind. Keep that in mind when we pick the right thing. Yeah?
Why is the cosine of sine x if it's x over 2? Like, is there a reason?
Yeah, we use the identity.
Okay.
I use the half angle identity that says if I have tangent x over 2, I can replace it with 1 minus cosine x over sine x.
How did you know to pick that one?
I knew to pick that one because I said cosecant is 1 over sine. And since sine is on the bottom, I'm going to try to pick one that makes sine on the bottom. Because if I would pick this one, see all the square roots? I don't have any square roots on the other side, so that's a dumb one to pick. This one has sine on top. I wanted sine on the bottom, so it gave me a good inkling that I should probably use this one.
So like secant, would you do one with like secant on the right side?
So I'd try to find one with maybe cosine on the bottom, so maybe I'd pick this one, because secant would put cosine on the bottom, so I might pick that one. Okay, so now we have to pick another one for this tangent x over 2. We want sine to be in the denominator, but we have to keep track of the fact that I'm going to flip whatever fraction I write. I actually need to pick this one. Since it's 1 over, and I'm going to take the reciprocal of it, this is the one that's going to put sine on the bottom. So we're going to pick this sine over 1 plus cosine. And I'll show you why in a second. So we're going to pick the sine x over 1 plus cosine x1. Because now I'm going to have 1 minus cosine x over sine x. I'm going to flip that other fraction because that's what 1 over it does. And I'll have 1 plus cosine x over sine x.
Pretty much keep change flipping.
I'm just, yeah, that's all 1 over something does. 1, keep, change, flip, flips it. If you have 1 over anything, it flips it automatically. That's all 1 over does to anything. 1 over 1/3 becomes 3 over 1. It flips that fraction. Common denominator. So we can add these. So that's going to give me 1 minus cosine x plus 1 plus cosine x over sine x. Negative cosine x plus a cosine x, that cancels out. Don't accidentally cover up this 1 because we do have 1 plus 1, which equals 2. So now we have 2 over sine x. What's 1 over sine x equal?
Cosecant.
So what does 2 over sine x equal?
2 cosecant.
2 cosecant. We're done.
Wasn't that good?
It's not that bad. It just takes, I've said this a million times, these take practice.
Yeah.
These take practice.